Right, we've got our differential equations question, C4, the old specification, June 2015, question 7, some partial fractions there, and a differential equation to solve. And here we go. So we'll do the partial fractions first. We write it as something over p plus something over p minus 2, something else, multiplied through by p times p minus 2. And you can put in p is equal to 2 into here, that'll make that 0. So you'll have 2 is 2 times b. You can put 0 into it as well, and that'll make that 0. And you'll have a times minus 2. And you get a is minus 1 and b is 1. So it's going to be 1 over p minus 2, and then minus 1 over p. And then it's a team of biologists studying the population of a particular species of animal, and the population is modelled by that differential equation. So the rate of increase of the population, that's how they reckon it's worked out. P is the population of thousands, and T is the time measured in years since the start of the study. P is 0 and T is equal to 3. So the population was 3,000 at the start. And we're going to solve the differential equation to show that p is equal to that. So we've got to get the form p equals. Right, first thing we do is separate the variables, get the t's on one side, p's on the other. So I would multiply by the dt, stick the dt up here with the cos 2t, and then take all this over the other side. So divide by p times p minus 2 and multiply by 2. The 2 goes up there, and the p times p minus 2 go down here. And then, of course, we've got to integrate both sides. We're going to use the partial fractions we did in the first part of the question. So we write this in the partial fractions form, which we can then integrate. So this is going to be ln of p minus 2 minus ln p. And this is a half sine 2t. Cos integrated is sine, but I need a half in front, so I differentiate sine 2t, I get 2 cos 2t, and then I need a plus c at the end, which I can work out because I've got these initial conditions, p is 3 when t is 0. Putting that in, I'll have ln 1 minus ln 3, sine of 0 is 0 plus the c. Ln of 1 is 0, of course, so the c is just ln 3 minus ln 3. We'll then put that into here, and that gives me that particular solution. This is the general solution of the equation. This is a particular solution using those initial conditions. And I wanted to say this, so I need to get the p's all together, but I need to get rid of the ln's as well. So I'll get all the ln's on one side. So I'll have plus ln3 over here, I'll have minus lnp, I've got a plus p minus 2. So I'll have a 3 on the top and the p minus 2 on the bottom, on the top, and a p on the bottom of the fraction. So the minus lnp, but I've got plus p lnp minus 2 plus ln3. That's equal to half sine 2t. I can e both sides then to get rid of the ln's, and they look like this. If I multiply by the p, because I don't like this fraction, and multiply the bracket out because I want to isolate the p, get the p on its own. It looks like this. P times e to the half sine 2t, and then it's 3p minus 6 on the left hand side. I'm going to take this term over and the minus 6 over as well. So to get the p terms on one side and everything else on the other, I can then take out the p out as a factor. 3 times e to the half sine 2t is equal to 6, and divide by that factor, and I get required result. Last part of the question said, find the time taken for the population to reach 4,000 for the first time. Give your answer in years to 3 significant figures. So my p is going to be 4, because the p was the population in thousands. So 4 is equal to this. I'm going to flip these over, and then I'll take this over the other side, the 6 over 4, which is 3 over 2 over this side as well. So I'll have e at the half sine 2t equal to 3, take away 3 over 2, which is just 3 over 2. And then under the ln's both sides, half sine 2t is ln 3 over 2. And to get the t, I'm going to have to double both sides, then do sine of -1, and then halve the answer. So half sine -1, 2 ln 3 over 2. It's all in radians, of course. It's a differential equation. Stick in the calculator, you'll get 0.473.